Hello there and welcome to the second video of the data communication and networking for the advanced level ICT class. I am Sanjay Bushmans. In the last video, we discussed about why we need an IP address and what a network ID is, what a host ID is, and how an IP address is created, and we saw some formulas related to IP addresses, and also we calculated the network and the broadcast ID when an IP address was given. In today's video, we will be talking about classes of IP addresses. Classful addressing. In classful addressing, the address space is divided into 5 classes: class A, class B, class C, class D, and class E. Each of these classes occupy some of parts of the address space. So out of the 4 billion addresses that we saw in the last video, we are going to divide all these 4 billion addresses, 4 billion plus addresses, to 5 different groups in classful addressing. We can find the class of an address when the given address is either binary notation or by dotted decimal notation. Now, when I give you an IP address, you should be able to find out what class it is going to belong to. So even if I give it to you in the binary notation or using the decimal notation, we should be able to find what class this particular IP address belongs to. If the address is given in binary notation, how we are going to find is using the first octet. You can tell whether this class this IP address belongs to class A, B, C, or D. If I give it to you in the dotted decimal notation, the first byte defines the class. That means the value, the decimal value of the first octet. The first byte is going to give you the class. So using either binary notation or by dotted decimal notation, you can find out which class an IP address belongs to. Now we'll use a table and see how these classes are defined in dotted decimal and the binary representations. The first table is going to tell you the binary notation. In the binary notation, you can see here what I have given in red is going to tell me that if the first value is 0, then it belongs to class A, and the rest can be anything of zeros and ones, and the second octet, third octet can be anything. So the first octet is what we consider when we are identifying the class. So if the first value is 0, then it belongs to class A. For class B, if the first value is 1, 0, it belongs to class B. For class C, 1, 1, 0 should be the first 3 values. Class D, 1, 1, 1, 0, and the rest can be anything. Class E, 1, 1, 1, 1, and the rest can be anything. So this is how you identify the classes if you are given the IP address in binary notation. Now let's see how you can identify these classes if they have given you the IP address in dotted decimal notation. Now this is the dotted decimal notation. You can see in this class A, the first octet, the decimal value of the first octet should be between 0 to 127. The first value should be 0 to 127. Then class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. Class E, 240 to 255. Okay. Now remembering this is very important when you're doing calculations or when you're answering questions for your examination. So I will teach you a easy way to remember this rather than memorizing these values. So let's get on with the binary notation first. If you see in the binary notation, I told you the first value of the class A is 0 and the rest can be anything. For class B, it's 1, 0 and the rest can be anything. Class C, 1, 1, 0, the rest is anything. Class D, 1, 1, 1, 0 and the rest can be anything. Class E, of course, still we have only 4 digits. All 4 will be ones and the rest can be anything. Now to remember this, you can see a triangular pattern with the ones that has been displayed if you put these classes in order. So this is how you remember the binary notation of class identification numbers. Then let's look at the dotted decimal notation. In the dotted decimal notation, I am going to make use of this number line. If you can remember, for number conversions from binary, this is 2 to the power 0, 2 to the power 1, 2 to the power 2 is 4, 2 to the power 3 is 8, 16, 32, 64 and 128 as follows. Now since we are using 8 bits for each octet, I am going to use until 128 in this. So we know that these IP addresses or the octet, the value, the decimal value in an octet can be between 0 and 255. So the numbers that is going to come in between should be between the values 0 and 255. Then the ranges can be given using this number line. Let's see how we can do that. Let's first fill the starting line for A, B, C, D and E. So we have already written the starting number for A as 0. Let's see how the others will work out. So the first one in the number line is 128. If I take this 128 and apply it for class B, that would be my first starting digit for class B. Now for class C, I'm going to take 128 plus 64, which will give me 192. I'm going to add the first two numbers in the number line, where I will be getting the value 92, and I will use that in the third row. That is, for class C, the starting value will be 192. Now for class D, I'm going to take 128 plus 64 plus 32, which will give me 224. And I'm going to use that as the starting value for class D. Then class E, 128 plus 64 plus 32 plus 16, which will give me 240, and that will be my starting value for the class E. So when you have the starting values, it is very easy to find the ending values because it will be one less than the next class. So for class A, if it is 0, the starting point, and if class B is 128, the ending of class A should be 127. Then if C is 192, the ending of class B should be 191. If class D is starting with 224, class C should have 223. If class E is having 240, then class D should finish with 239. So this is how you find the classes using either binary notation or dotted decimal notation. In IP addressing for advanced level, we will be talking about class A, B and C, and we will be doing calculations on class A, B and C. But we will not consider class D and class E in your syllabus. This is because class D is used for multicasting and class E is still under research purposes. So we will be doing our calculations, all our questions, everything will be done for class A, B and C. But still you have to remember how to identify these values, identify the classes using the IP address, the first octet, dotted decimal or binary notation. Each of these classes has a default subnet mask. If you recall what a subnet mask is, a subnet mask is something which is going to divide the IP address into two parts, that is one part for the network ID and one part for the host ID. If you see in classes, in all these classes, a subnet mask, a default subnet mask is given for each class. For class A, B and C, we have a subnet mask for each of these class which is default, which is not going to change. So we will put that down into this table. Now in class A, B and C, we have the classes A, B and C, and the subnet mask we can represent it either in dotted decimal representation or binary notation representation. For dotted decimal for class A, it will be 255.0.0.0, which is going to tell me that the first octet is going to be all ones and the rest will be zeros. For class B, we will have 255.255.0.0, which will be illustrated in the binary notation as 16 ones and 16 zeros separated by dots. For class C, we have 3 255 values and a 0, which will be represented in the binary notation as follows. So if you see the red part of the binary, I'm going to discuss about the binary notation here. The red part of the binary notation is going to tell you the network ID. So all the ones are going to represent the network ID, whereas all the zeros will represent the host ID. So in class B, the subnet mask will be divided into two: network ID 16 bits and host ID we have another 16 bits. For class C, I will have 3 octets for the network ID and 1 octet for the host ID. So this is how the classes have been given a default subnet mask. All these subnet masks cannot change, will not change in classful addressing. Remember, in classful addressing, your subnet mask cannot change. It is a default mask. For each class, the subnet mask is permanent. So that's it for the video for today. In the next video, we will be discussing about blocks and number of networks for each class that can be calculated. And we will be talking further about subnetting and side annotations in the next videos to come. So until then, this is Sanjay sir signing off. Take care and God bless you.